Hi, my name is Adam Andrus, and today I'll show you how to make your first simulation in Solidworks. In combination with designing and assembling parts, Solidworks is also a great simulation tool that offers a wide variety of simulation types for many different industries. These simulations are helpful in seeing what a part or an assembly will do when you put under conditions in the real world. This analysis helps engineers see a part's behavior before it is even made and is widely used throughout every engineering industry. This is a simple tutorial on how to make your first simulation, which will be a simple stress analysis of a cantilever beam. First thing you want to do is open Solidworks. And open a new assembly. Once you're in the assembly design studio, you can go ahead and open a simple beam that you can easily make in the part design studio. And here you can place it. Now, once you have the beam in the design studio, you can go ahead and go to your SolidWorks add-ins. As you can see here, my simulation add-in is already clicked. So you can come back here, or you can go to the simulation tab and start a new study. Now the study will be a static study. So you select static, click check, and now you can start applying your constraints to this beam. First constraint we want to do is a fixture. So we want to, as you can see here in this picture, we want it to bend like that, like a cantilever beam. So this face right here will be fixed as such in this picture. Once we do that, we can go ahead and add in a load. So we can come here to our load divisor and click the drop down menu to select force. Once we're here, we can select the top of this beam to add in a force on it. Now we can just select a fairly random number and we can change the force type right here between SI units, English, or metric. I usually stick with English as we are in America. And we can go ahead and set it at 800 pounds. Once we have this, we can go ahead and click check. And now we can go ahead and apply our material. So up here in this top left corner, you'll have apply material. And this is the dialog menu that shows you every material that SolidWorks has. So we can go ahead and apply ours as just a normal, say, 1020 steel. That'll work. I hit apply. Once you click apply, it won't go away, but it is applied, and you just go ahead and click close. And you can see here that the check mark next to this little box means that it has a material applied to it. Once we have all this set up, we can go ahead and click run this study, and this will go ahead and apply a mesh to the beam, and then go ahead and run the study on how it will stress and bend. So as you can see here, with the 800 pounds of force on the top of the beam, it has the most stress here at the fixed end, which is expected, and is easily seen with the heat map of where the part is the most stressed. Now you can change many things of the part to make it stronger and stronger and stronger. This is a simple I-beam, which is great for this type of loading, but as you can see, too much loading will end up in bending. Other tools you can use to look just how much it would bend is up here. You can click deformed result, which it will automatically show you the deformed result, but you can go in between deformed and non-deformed so you can see just how much the beam is moving. Other options here are displacement. This shows which parts of the part move the furthest. As you can see here, the end moves the furthest. And then strain. Strain is how far the material moved in relation to where it should have been. So how much it would have bent, actually bent, rather than just moving a little bit. As you can see, the end here stayed straight, but over here it bent, and so that's why there's strain there. But as you go back here, the stress map is usually the most important, and it gives you the best idea of where your stress is throughout the part. There's many other different tools you can use throughout here. There's different interactions here that you can use between parts and assembly. So you can run analysis on a assembly that can be we can go here to new study, I can show you more. That can be a topology study, design study, thermal, buckling, fatigue, nonlinear, so some nonlinear stress, dynamic, so harmonics. There's many different types of studies you can make and many different ways you can put a part or an assembly under conditions to show what it will do in the real world. This proves to be very helpful in designing to see just how the part will actually behave and really give you a good idea of how you need to change your part to make it better. As you can see here in this part, we would need to make the web thicker or just in general the entire beam thicker to be able to support this load. So go ahead, I would encourage to just go ahead and play around with this and see what you can really make and what you can really do to just something like this. I mean, this really is a simple simulation, but gives a good look at the basics of how to set this up and how to show you what it takes to run the simulation and what the results mean. So thank you for watching, and I hope this was helpful in making your first simulation. Thank you.